Prabir Patra. I know him since the beginning of my research career itself, that is for more than 25 years now. And as we did PhD in PRL in same department under the same supervision. So it is always, valuable to interact with Dr. Patra. So let me formally introduce Dr. Patra. So he's currently a professor at Research Institute for Humanity and Nature, RIN, in Kyoto. As a principal scientist and deputy group leader, he's there in Japan Agency for Marine Earth Science and Technology, JAMSTEC, Yokohama. Dr. Patra completed his PhD from Gujarat University in 1998 based on the work done in Physical Research Laboratory. So during his tenure in PRL, he significantly or remarkably, his contribution is remarkable in the success of several research programs. And two most important programs are ISRO-DB program, where he was involved in the vertical distribution of trace gases using balloon-bound cryogenic air sampling instruments. And then the second was JGOBS, in which we studied the sea air flux and ocean biochemistry of nitrous oxide and methane in the Arabian Sea. So after PRL, he worked at IBM India Research Laboratory for about 3 years, 1998 to 2001, before moving to JAMSTEC. In JAMSTEC, he has been working and leading the key research programs related to the simulation and measurements of greenhouse gases and air pollutants in the atmospheric and ocean atmosphere. And since 2023, he is also is leading an important project that is called ACAS project in RIN. So Dr. Patra is well known, and he has published about 190 peer-reviewed publications. He is involved in various professional activities, like he was kind of Biogeoscience Section President, Asia Oceania Geosciences Society. He is editor of Geoscience Legislator. As a science team member, he was involved in NASA and WMO also. He is the associate editor of Remote Sensing. He was the lead author of the 6th edition of the IPCC. And he is also the scientific steering committee member, SSC member of Global Carbon Project. Dr. Patra has received numerous awards and honors. He has been awarded the Outstanding Research Achievement Awards from the FRSGC for several years, 2003, 2005, 2006, 2013, and 17. JAMSTEC Research Achievement Award during 2011 and 2019. And he also received the Hority Award from the Meteorological Society of Japan for significant contribution in interdisciplinary fields related to atmospheric sciences. Dr. Patra is also associated with various reputed societies like American Geophysical Union, American Meteorological Societies, Indian Meteorological Societies, and Japan Geosciences Union. So with this brief introduction, of course, I can say many more about Dr. Patra and his research work. So with this, I conclude the introduction part, and I invite Dr. Patra for his presentation. Over to you, Dr. Patra.
Thanks, Lucas. Thank you very much for the nice introduction. So my slides are visible, right?
Yes.
Well, and then you can hear me. So yeah, so I today in this talk, I will not talk about my 20 odd years of research in JAMSTEC. So, but instead I will focus on the air pollution issues, which are we are working on from Chikuken in the RIN in Kyoto, and where I have been involved deeply for last 2 years. Of course, I am part of the project from the beginning, from the inception, and then I have been leading this project for last 2 years, and I will try to summarize like the approach we take here, because it's not very normal, that not so much common that people do research on the transdisciplinary viewpoint. And the RIN, which is Research Institute for Humanities and Nature, you can see the Research Institute for it's more humanity and nature than the pure science. So we of course we are allowed to do science, but the science we do should have a direct implications for the humanities and nature, which means that we want to preserve nature, we want to help the humanity to be sustainable, and that is the main goal of our institute in Kyoto. I'm not going to talk about much of the introduction of the institute. There are enough information available for this. So, but what we do in the AKAS project, which is okay, in RIN, we have several projects which runs for 5 years. So this is the final year of our project, and we'll finish with the fiscal year at March 31st. And so we kind of have all the work done in our project as much as we could do, and to study the particulate air pollutions in the northwestern India, and basically to promote sustainable agriculture. Because you all know that, so all the pictures you see in the bottom, we have been discussing that the crop residue burning. I will be calling it CRB, crop residue burning.
Kindly be muted.
Okay, so the crop residue burning, which is CRB, and then it is mostly happening in Punjab right now, and it also happens in Haryana, and the other two neighboring states, and by distance as well as by the wind connections. So the time when these crop residues are burnt, which is October, November, and that time the monsoon system retreats, the southwest monsoon retreats, and then we start to get the wind from the northwest directions, from the north and west. So then this crop residue burns in Punjab and Haryana, it can naturally flow to through the Indo-Gangetic plain, because we have a Himalaya on the north, which is blocking the release of the air pollution to the upper atmosphere, or the winds also slows down, as we have discussed a lot of time. So this is why I am showing this picture, that most of the research is involving how to manage the crop residue, how to manage it sustainably, how not to pollute the air pollution, how not to pollute the air, and which is, of course, we talk mostly here about Delhi, not national capital region, because lots of people live there, like 70 million or something like that people lives there. But I think the people who lives in Punjab and Haryana should also be affected, which has not been discussed so much, and I will try to say a few words about it. So these are a few pictures I just took from January, wherein I visited the Punjab. So one thing that we can see, that the transition we should see here, the basmati rice straw which is lying on the field here with the bhatti sensor here, so you can see him standing. And so they are very thin rice straw and not so big stubble. So maybe up to the waist height. But look at the high yielding variety, which is like a Parmal rice or the Pusa 44. The height of this rice straw is taller than me, and the thickness of maybe my little fingers width. So it means a lot of rice straw is being produced in the recent times, as the high yielding crop varieties are being adopted in the Punjab since 1990s in India as a whole. And then as I mentioned, our work goal of this project is to sustainably do agriculture, sustainable with the humanities. So then we have to work with the people on the ground who are actually doing the farming. So we try to discuss with them, we try to exchange information with them, what they do in the field, and how their field is being processed. Because I will tell you later on, I mean, next slide itself, I think I should go there, is that we discuss how what are the constraints the farmers have in terms of the climate, in terms of the water cycle, in terms of the temperature and all the things. So because they don't do the farming based on just their own wish, it is a natural system which also supports so far, and we probably deviating, and that's the reason why you need to talk about sustainability in terms of crop residue burning and etc., and in cultivation. So then so if you look at our project goal in this case, is that we want to change societal behavior by raising awareness about air pollutions and health effect based on our observations. We need to have observations from the ground, every place with whom we work. And then we try to also look at the cultural, geographical, and economical backgrounds. And in addition to the climate system, which actually drive any cropping system. So some places we do rice wheat cropping, double cropping system. Sometimes we can grow 3 crops, and some places like in Japan or the colder country, we just only grow 1 crop. So all these things are determined by the climate system also, which we have to link the climate and society, and geography, everything together to understand the system as a whole, and then try to come up with solutions. So then we actually explore potentials for effective use of straw. There are many options. Then also they can we also think about doing suggesting the crop diversification, which is not a new idea, but I think we can also show by field experiments is that crop diversification is can be a reality. So we do all the sorts of things, and eventually you also want to look at the low carbon society, because if you do reduce air pollution, but if you do other environmental damage, which is like air, one of the things we talk about climate change, the global warming, then that is not, again, not sustainable. So we need to slightly also look beyond just air pollution. And so these are the things we wanted to do in the beginning of our project. And then let me go into the details a bit, and how the climate determine the constraint on the farmers. So this is what you see, the bars in this plot in the top panel is the temperature, and the temperature is written here, and it's like going from April to next year June, just to show you the climate, how it varies. And the rainfall is very much monsoon driven. So only 3 months we have rain. And then wheat is a traditional crop in this region, so everyone knows. And then the local people all eat basically wheat-based meal. So that is a staple food. But rice was introduced in 1970s, as a part of the Green Revolution, to provide food for the whole country, as a whole country. Because before, in the 1940s and 1950s, 60s, we had famines in India. So I think government of India done remarkable job by bringing this Green Revolution. And today we talk about the food sustainability, because all started in 1960s and 70s. And this Punjab and Haryana rice is one of the key factor in avoiding many famines in India, which could have been without this support. So imagine the power of this cultivation system, and today we're talking about this other issues. But how this issue suddenly arise? It is not suddenly it arise, but so that we had been having the monsoon rainfall, we grow rice, we have the cool temperature in the winter, we had the wheat productions, and then the machineries came in, everything like we now do different, because you do mass production, because this has been increased in the rice crop area. And then also the machines have come which process the crop harvesting very differently from before. And so then what happened is that with the rice crop being intensified, there was a concern about the groundwater depletion, which is still happening in Punjab and Haryana and most of the part of the country, but more severely in Punjab area. So then what the government policy was implemented in 2009 is that you delay the rice cropping. The delay means what? So this temperature curve is very important in this case, because we have been like starting to seed and then plant rice in around June, for example, May, June, that time frame. But then in this time, the temperature is very high. So that means that you have a lot of evaporation from the rice field with a high temperature. So by delaying this by about a month, you actually save water, that you don't have to pump up so much water. Then the rainfall comes and the temperature goes down, so you save the water and groundwater pumping up. So then what happens is that then you have a narrow the gap, or the wheat seeding is very fixed, because that depends on the climate. You cannot have a rice wheat productions in high temperature beyond 20 degrees or something. So then that is fixed, that cannot be changed. So this rice cropping cycle was slightly delayed. Then what happened that we narrow the window of processing of the rice straw. And then you also have like a high yielding variety, which is introduced again and again, and also more resilient, climate resilient, and the pest resilient crops, which are having more straw, and the processing part becomes very difficult for the farmers. And then I also believe that if you burn the rice crop on the field, you actually will keep the soil carbon content maintained. So which means that for the farmers, it is double win situation because they can preserve soil carbon health, and also there is like some other pest or the insects which cannot continue for the wheat cycle are also burnt out by the crop residue management they have been implementing. So many things have gone on, and then this is how where we are today, or maybe where we are today. Basically, a lot of crop residue burning in Punjab. And this is in our three working groups. We work on the clean air development, we work on sustainable agriculture, and we work on the health a little bit. So further ado, I mean, so I just go into how you do this. So basically, we have to do a lot of survey because this is a so research of the social scientist. So the social scientists do a survey to go to the field and talk to the farmers and ask questions and somehow summarize their circumstances. So this is one of the examples. What they do is that they do the survey. So in this case, we did like a 2,200 household survey was done in the time of COVID. And then they kind of generate this map by saying that which part of Punjab, like Majha and Malwa and Doaba region, how they are different, and how the people in farmers in this area treat the crop residues. So if those who have also seen the fire count map, we could actually relate this pattern within Punjab. And but this is produced by the survey so that we can see the power of the social science in generating also the reasonable and a good understanding. So and how this pattern arise also depends on the practice they adopt in terms of and farming of rice and then rice wheat and cycles and etc. So there are many details. I will not go into much details, but I'll show you the minimum things I need to convince you that why the social science part is important when even work on the air pollution, which is we think as a pure science thing. And so what they now relate is that in Malwa region, which is the southern part of Punjab, is that they grow a lot of Pusa 44. Those who know the rice cropping varieties, Pusa 44 is the high yielding, it was introduced in the 1990s, early 1990s, and it is still the highest growing yield rice variety. But it also produces a lot of straw. As I mentioned, the straw size and length and thickness is very big. But if you go to like the other regions, like in the Majha and Doaba region, they don't grow so much rice, Pusa 44. They have a Parmal rice or the PR, very many variety of PRs, and the PR basmatis. So because in the Namritsar, if you go there, you grow a lot of basmati, and the south, and then this part Ludhiana and the northern part is a bit more also industrialized, so they don't grow so much rice, for example. And then the rice cropping, rice, that means there is a variety of cropping system they adopt. But in this part, the Pusa 44 being so highly practiced that they produce a lot of crop residue, and they have no option than burning them as of now. So then we also have to relate these things, why these things differ by farmers to farmer. So then you can also see this kind of, you can make a chart like this. So who does the full burning? So they also have a less access. They are typically smaller farmers. They have marginal farmers. They don't have access to machines so easily. They don't own the machine at least. They have to like rent it. And when you rent it, it doesn't come to a small part, but they will go to a big farmer's house because they can get a lot of land at one time. So then you can see that you can relate to the like Pusa 44 different color rice varieties, and then the more expensive machines. The newest one is super seeder, so which can actually process the field pretty well, even with the lot of rice straw left on the field. So no, all this economics are also put into our model, where they try to combine what conditions the farmers kind of adopt to do the practice they do. And so you can actually can clearly link those practices to the cost of the rental of the different machines. So you can see that it's almost like 5 times more expensive to rent the super seeder compared to a simple drill, which the the marginal farmers adopt, and which this gets it's like the rich farmers which have bigger land and maybe 20 acres or something, so they basically own this kind of machines and they do this kind of thing. But then, so another things comes is that how the land rent changes with the time, and how the how much fraction of the land is actually owned by farmers and how much is like rented by the farmers. So all sorts of things we take into account and develop the economic model to understand what could be the solutions. What are the current situation and what could be the solution to and what kind of even subsidies for the, or if government is offering a subsidy, what kind of subsidies the farmers should need to adapt to the machineries they are recommending in terms of not burning the rice straw but processing on the field without affecting the climate, and then their crop yield. Crop yield is the major factor because their income cannot be compromised if you want to tell them to change. So we do all the things, and then you also process. So our colleagues in lovely professional university, so they do a lot of management testing. So we have plots and where we do the crop experiments to, and we calculate how much crop is like a processed as a biochar. So you can make biochar. In the case, like, when you do open burning, all the PM 2.5 and the gases escape to the atmosphere. So that could produce our air pollution problem. But the way you make biochar, so then you don't actually release that carbon component or compounds in the atmosphere. So you actually keep them. You don't okay. So for example, somebody was telling me that if you burn a 20 tons of rice straw, you will probably produce maybe 4 to 5 tons of the leftover on the field, which means that rest of the things have escaped to the atmosphere. But if you make a biochar, you can actually make maybe 12 ton of biochar out of 20 tons of crop residue, which means that a lot of the carbon, all the residues which are like flying, will remain in the container where we process the rice straw to make biochar. And then this biochar also has, like as you mentioned, that biochar is needed for the soil because to maintain the carbon content. If you just take all the rice straw out of the field but don't leave the enough carbon, then the soil health will not be maintained. So then this biochar is again applied with different fertilizers combinations, and we do all sorts of testings, the germination, the growth, the yield. So everything is calculated and then shown to the farmers. We show to the farmers that what happens on the field if you apply such things. And these fields are prepared like that. Farmers are bought into the system to show that what are you going to gain or lose if you adopt a particular method. And so all these things also, we also try to do different crop like turmeric or the papaya fields, and several other things in the field to experiment that what the Punjab climate and the water system and the temperature system can actually support. So with I think all these things we can summarize the part we do in terms of like social science and then farmers involvement, and this is kind of I will not go into details. So we study many events, what policy was implemented and what is the effect, what are the rice varieties and how they have been managed. So all the things we put together and to make a nice story. So I will not discuss much about it. But I think next maybe 20 minutes or 25 minutes, I will try to focus on the air pollution issues, which most of the IASTA people probably are interested. So many people have already seen this kind of chart from us. What we saw in the left is that the blue is the observation points of the government existing right now in India. And what you see in the Punjab region, which is seen as a red here for the fire hotspots, are not so much covered. As I mentioned, the southern part of Punjab is having lots of crop residue burning. But in the southern part, we hardly have any observation locations in our existing system. So what our project did is that, of course, our project started from 2020, but then we ran into COVID pandemic, and our 3 years was completely 2 years completely wasted. But last 3 years, like 2022, 2023, and 2024, we have observations. And these observations are done in a way that we cover the whole part of Punjab and Haryana and going to Delhi and downwind, so that we can see the flow and the growth and the decay of the PM 2.5 concentrations in the whole region, so that we can link it up with the ground realities and the satellite observations and the what we hear from the statistics. And our instruments is very simple, which is like it's called low cost sensor. It costs something like 300 US dollar, or like, yeah, maybe something like yeah. And so we can calculate them. So it's that kind of instrument. It can measure PM 2.5, of course. It can measure CO. It can measure temperature and humidity. And oh, I forgot to measure. It also measure also NOx and ozone as a oxidants. But I will mostly talk about the PM 2.5, because in CO and ozone and this one, we are still doing the lot of QA QC. And our main focus also is in the human health from particulate air pollution. And so this is we just prepared this kind of plots in last 1-2 weeks, and then I will try to show you. And Akash is working on this, and Poonam is also doing this kind of objective analysis. So what we do in this case, we might have sent my time series. I will also show you time series from our research. But what is shown here is that the observation site locations are shown each panel from 2022, 2023, and in the right 2024. And those data can be like do kind of go through the objective analysis, which is done very commonly in the meteorological field. So then we can make a map out of the observation sites with the inverse distance weighting. We can actually extrapolate in between, sometimes even go beyond the measurement areas. That is just extrapolations. And then on the bottom row, you see that it's just fire counts from VIIRS satellites. So what you see in this case, that the PM 2.5 is actually very high in the Punjab region, and more likely on the southwest Punjab, and then also Haryana in the north sometimes, in the south sometimes. And before, I mean, we have been only talking about Delhi, but look at the PM 2.5 in the Punjab regions. It's become really like a 500, 400 micrograms per meter cube very often. Sometimes, and then those are actually, of course, PM 2.5 has a lifetime of 3 to 5 days, so they can be carried in different parts of the country by winds, depending on which direction the wind blows. And the day-to-day variations are very large, because it can be from the in meteorology, it is also from the emissions, it is also from the sometimes the wind directions, and also there is external cross-boundary transports. So everything happens in this case. And what one thing we noticed is that in 2024, all the fire crop residue burning happened in the mid-November and later on. Before that, I think in the 2022, we saw that it's more spread from October 15 to November 15 in that 1 month. So there have been a lot of shifts in the policy and how the government is trying to manage the crop residue burning in the field. So then those things are also reflected in these maps. And we can actually explain one by one. And to make simpler, I will go to the next plot to show you the time series plots. So in this case, you can see that we have measurements for 3 years, 2022, 3 and 4. 4 is red and blue is the 2022. And this is Delhi and NCR, which is basically Gurgaon, and then this is Haryana, and this is Punjab, east and west. So as I mentioned, that this part of Punjab has seen very high PM 2.5 concentration. This is 6 hourly mean values here in this case. So many times we see like 500 micrograms, and it is lasting for like 2-3 weeks. This is, I think, quite remarkable in terms of what these people experience there. And when I go there, I went there in January. I can actually, the farmers say that in this period when this kind of high pollution are occurring, the elderly people are slightly ill people do not go out of the house. The teenager kids do not go to school because it's too much polluted. They cannot do well for the health wise. So lots of social implications even for the village areas. And what I was trying to show in this also in this case is that 2024 has been very nice in terms of like how it has been evolving for the PM 2.5 concentration until about November 12, 13. But then we have seen a burst of PM high PM 2.5 cases, which is reported in the media and everywhere else. So these kind of things we have been discussing, and Poonam's paper is out in the NPJ Climate Science. And so then we have also done many press release on this. I think it has been quite well accepted, and we are happy that these measurements actually works well. So works well in a sense that I can tell you that one thing we do this calibration of these instruments in Japan by Nagoya University, Matsumi Sensei and Nakayama-san. But also we see on the field deployment. So we see that when you start these measurements in early October, all the instruments start from the similar conditions, because the crop residue burnings are not so common, and October is like still like under just coming out of the southwest monsoon. So then most places are quite clean, and then each instrument picks up the local signals as the situation moves. And by the end of November, again, we see a very common concentrations, most part of the country, where again, so the all extremes are gone. Now we are come down to a normal level of PM 2.5. And so then we can come back. So the instruments actually, these are low cost sensors. So then we had a lot of thinking like how well they work and whether their quality and other things. But I think now we have kind of successfully proven that the instruments can be done, can be deployed and maintained successfully for a longer period of time. So some of the instruments working in our collaborators places like Bhakti Sensei here and other places in JNU, that they work for like 1 to 2 years almost without any trouble. Sometimes we just do a minor maintenance. And these instruments can also deliver data over the internet when you have a SIM card attached to it. And so we have been actually following very closely in every year, 2023 and 2022, when the data coming in, and we have been following this year's event of PM 2.5. I would try to focus a little bit on this. So what situation we kind of can capture in our instruments is that here we are showing the 3 instruments from the 3 different organizations: US Embassy and ITOs, CPCVs, and the JNU, our sites. And then we can see that then the Diwali event happened, and then there, of course, the difference between the instruments, and we know that the local conditions varies, and you can see here. But what I will try to show you here is that how the crop residue burning can affect this kind of situations. And that in 2024, I think that the government regulations and then the policy was very strict on the zero tolerance on the crop residue burning. And I think the farmers were holding back of their burning the crop residues in the field or something like that. And something around 13 November, we see a very large some fires, which is shown as the black and black setting in this in this slide. And then the red dots actually tells you how much is the PM 2.5 concentrations each site. And you can see that all the sites actually showing the PM 2.5 concentration at more than 300 microgram. So of this symbol size everywhere. So then we have a very strong build up, and the winds are also shown as the vectors here. They're very, very small winds. 5 meters per second is like this. So it's almost like a 1-2 meters per second wind. Sudden stagnation happened. And it happened, and on the next day, we had even further stagnation. Of course, we don't see so many fire hotspots, but the wind stagnation was remarkable. It's like a standstill. So then this build up the PM 2. And keep the PM 2.5 concentration almost same concentration, like 300 microgram or more, or the whole place. And then by the time you come on this 18th, which is like a terrible situation in Delhi, which is many of you saw the picture before my Dhaka sensor sent it, that nothing can be seen from Delhi's windows, house windows. But the 3 instruments we have in this case shows very different pictures. Normally they don't show like that. So we are really puzzled by what happened to the ITO site. And there are also many effort by the government to remove the PM 2.5 concentration from the air by the water guns and etc. etc. So it so happened that we found that one of the water gun actually placed to maybe this CPCB site, and that probably could have reduced the locally the PM 2.5 concentrations. So this policy and then the effect are actually very clearly seen, but the and also that what will let us think what is the best policy to this best policy to reduce or to control the air pollutants in the air, whether it's water gun or in the grab 3 4 5 and all the things. So then these things we keep doing. And as I mentioned, like 2024 was very remarkable in terms of very low fire count. This is one of the plot I show you here. That this is the here you are showing. I am showing two different parameters. The bars are the fire detection counts, which we can instantly see from satellites. So then this is fire count is the metric which has been used for policy making in the crop in India, and to count the how much fire is happening on the rice crop areas. But another term which we have like a burnt area, which is like a done slightly later. They take the weekly kind of scans and then they gather more information and produce a. For this is mostly used for the calculation of the emission inventories. So how much area burnt, and then you can multiply with the emission factors, but depending on the dry matters on the field, and then you can calculate the emission inventory. So by looking at the fire count and also the burnt area, you see a remarkable decrease. It's like a 70% decrease in Punjab in 1 year. So those are like a very eyebrow raising for us. Like, how do you reduce 70% of the fire counts in 1 year suddenly? Because machinery has been available for such a long time. But what changed in this 1 year that we could do this? But then if you look at our measurements as I showed, so 2024 actually shows higher concentration than 2023 or even previous years in some areas. So then we are like now thinking like how it is possible that the fire counts of the burnt area has gone down, but the PM 2.5 remains so high. And we then need kind of a model to experiment these things. And so our colleagues in REEN and Jamstack working very hard to set up the model in last less than 2 years time. And we run many experiments to analyze these situations, because without doing the kind of a process level modeling, we cannot really assign one cause or the other to the what is happening on the fire counts on the burnt area and what is happening for the PM 2.5 concentrations. Because there is atmospheric chemistry and the transport in the middle, which we do not account just by looking at the observations. So the modeling helps us here, and we are doing this kind of, this is a typical WarpChem setup. So I can see that all the list here, and then we input all the Edgar and then pin and biomass burning, and then on the whole area, and we do this. The domain 1, which is a coarse resolution model, it covers the whole Southeast Asia, and and then the 9 by 9 kilometer grid, which we do analysis of, which is like it's mostly centering around Punjab, and do the simulations. So 9 by 9 kilometer grid is about the distance, a kind of a distance which is less than our measurement point distance. So then this 9 by 9 kilometer model actually should be able to resolve the observation differences we see at various of our QP observation sites. So that is the idea, to have settled for 9 by 9 kilometer. You can go down to 1 by 1 kilometer, but then it's very expensive, and then it's sometimes difficult to manage to run many cases. So what we do in this case, we actually run 5 cases of model, because we want to check different things. One is that the warps control. CTL means control, and it has all the normal things. But in one case, we just run warp no biomass burning, no BB. So then this will be like this. So biomass burning part is taken out of the system, and just run with the anthropogenic the industrial emissions. And then one case you run the Punjab biomass burning, because one thing we want to separate how much is the total biomass burning, how much is happening from the just Punjab. because Punjab is one of our focus area. And then we have also reported that the cloud cover actually hampers the measurements of PM 2.5 or the crop residue, the even fire counts, because in the cloudy conditions or the hazy conditions and the smoky conditions, satellites do not see the surface. So then we do this kind of other experiments, and then another case like there are reports you must have heard that the people are talking that the Punjab farmers become smarter, and then they know that satellites are passing over our head at 1:30 or 10:30 in 1:30 p.m. or 10:30 a.m. So then they start burning maybe slightly late in the evening so that people cannot see it, or the administrators have gone home, and so nobody is there to catch them. So all sort of things. So this is the kind of so the model. This is the power of model that we can do hypothetical analysis to test our ideas. And if you see that one, the simulation case, this is one kind of map plot, is that this is a warp CTL. So the simulations, if you don't have biomass burning, you see a much lower concentration in the whole this Punjab, Delhi, and Haryana region. But if you just run with Punjab biomass burning, and then you can see that it is produces almost similar results with all biomass burning, which means the Punjab is a dominating factor in terms of what we see from the emission inventories. And then we can now do this kind of calculations like as you've done, like you simulate using control, and you can simulate without biomass burning. And then what we do is that we can calculate now the biomass burning share in the PM 2.5 concentrations. So what you do in this case, like WAP CTL minus the simulation is the no biomass burning divided by our control simulations, and that becomes like the calculation in this case. And then we divide these regions into 4 parts to be like able to summarize the result. Then these 4 parts are seen as in the North Punjab, South Punjab, Central Haryana, and Delhi in the different colors you see in the map. And you are talking like of course the southwest Punjab. This area is most affected by the crop residue burning. And in 2022, it was like 39%. In 2023, it's 48%. In 2024, it becomes drastically less because our emissions from the satellite measurements are very, very low. So that then if you come to Delhi, it becomes like almost half of the previous 2 years contribution just from the crop residue burning. So which is a good sign. But as I mentioned that our concentrations are very, very low compared to what is observed, because the biomass burning emissions is too low. So then we bring in that kind of the simulation cases where you say that okay, maybe there are too much cloud, so then we cannot see the surface, or where you say that the Haryana people are actually Punjab people are burning the crop residue in the night. So then these 2 simulations we can show here as a plot. As I mentioned, that the evening biomass burning means we actually shift our by default the model simulations actually taking the peak biomass burning emission at 2:30 p.m. because farmers burn in the daytime, which is very safe, and the straw is dry, soil is dry, very less humidity, so the burning efficiency is very high. But then they move to the evening. That means that it's like maybe around 6 p.m. So we do at 6:30 in this case. And these simulations on the left side is the control simulations, and then on the right side is the animation is in the evening biomass burning, the shifted biomass burning simulation. So what you see in that the upper part is a cross section with the height and latitude, longitude, and this line goes, the latitude longitude line goes to the white line here, and these lower planels are the surface concentrations. So when we shift the biomass burning, the crop residue burning to the evening time, you can see that at the surface, we always have a higher concentration. That is because when you are emitting in the night, your boundary layer is very low, and then the PM concentrations can stay very low in the surface. So they don't escape to higher height. And but when you burn in the daytime, this ventilation coefficient is quite high, and then things can escape outside our domain very quickly. So this is a method process which is being very nicely illustrated in this thing, the animation. And what it does also, you can see that we did the 3 simulations and for 3 different years. So if you just say that, okay, cloud cover days, we can try to somehow mix and somehow cover with the just some basic map of of emissions. So the control simulation and the mean biomass burning simulation does not look so different. This is a mean bias. So observation minus model bias. So observations are always higher and model is lower. So it's a model is like always lower. So what happens is that, but when you shift the burning time, so in the 2020 case, all the regions we actually see a remarkable improvement towards almost like if we add all the sites, all the regions, we almost come to a very balanced PM 2.5 concentration over the whole region. The negative bias in the model goes away. But what happens in the even so then this, you can always imagine that okay, biomass burning must be also happening in the night, and then we should propose to the improve the emission inventories and include a better diurnal profile. But even the same situation, if we apply in 2024, it of course it improves quite fit like a 30-40% it improves, but the values are still way below than the observed concentrations. So that means that even if you do shift to the night, you cannot come to the level of PM 2.5 concentration which is observed in the 2024, which means that there must be an underestimation of the emissions. Now, how you solve it? It's a puzzle for us. So I hope the next year's experiments and then we can design new things by our colleagues in different places because our project will be finished this year. So please get ready to see more, new things with your own infrastructure and deploy there. And I think this will be very exciting that this transition is happening now. And I think I'm very excited to know what is going to happen next. So we do some sort of a health impact studies. I think that is more, I will not talk too much. And it basically follows the same survey we have done in the Punjab and Haryana region. And now with the model simulations, we can also do is that we can quantify the health like a attributed mortality. This is basically based on the Bond et al. So the theory that we can calculate these numbers by in the population density and then the PM 2.5 concentrations and their exposures. And since we have the model simulations now, we can do like a and the map from the QP observations. We can have the map here for the observations, map here from the control of model simulations, map here without biomass burning. So, for example, if you remove all the crop residue burning, you can see the differences on the health of the Punjab population, which is I think very nice. But I think I will not dwell much on this at the moment. So to keep some time for the discussions, and then these are the kind of conclusions and outlook I have from our project so far, that the low-cost sensor networks works. And we define that the very large concentration of PM 2.5 in the suburb regions compared to the even megacity region in Delhi. So then I think we must be also worried about the health of our rural population. So we of course disseminate the results, and I think that it has to be like a government level mandate that the observation sites are placed all over the places so that we as an Indian community can actually observe the whole situation much better than what we do right now. And it has to be long term with a long term perspective because the transitions and the new things comes. And so we all have to be tracked so that we are not falling behind and to act. Like in this case of, I think that crop residue warning, we have been delaying these things for very long time, and we still have dilemma like what is going on and how much you can capture of the processes on the ground. So that I think there are still a lot of measurements and modeling, and then cross collaboration has to come. And so that we of course need to consult the farmers, and their economic conditions are always tight, as you know, but then they cannot be left behind as a society. So we do science, you have to take our society together in terms of the sustainability. So I think those are the things I would like to just talk today. With that, thank you very much. And this is a nice picture from the Golden Temple. Thank you very much.
Okay, thank you. Thank you so much, Mr. Patra, for such an interesting and informative talk. Whatever you said in the initial slides, many of the things I was not aware of. So thank you for sharing this. And obviously, results are quite interesting. I am sure there are many questions, hands are already raised. So what I would request that people to please please raise your hand and we can ask the question one by one. The first question is by Dr. Harish. Harish, please go ahead.
Hi, Prabir. Nice to see you online. And one of the most interesting thing was that in spite of satellites showing the decrease in the 2024, the fires and the burn area, you are still seeing the higher concentration. So is it possible that because the Akash network is in Punjab and Haryana, these fires might be happening, say, in Pakistan or maybe into the eastern part of the or outside the area where the Akash network, is there any indication of that, or no? That case is ruled out.
I mean, my slides went out completely, right?
Yeah, yeah, not going to that.
Yeah. So yeah, I think that was a kind of a question I was kind of expecting to some extent. So then I did not show you this one. So this is our India border, right? So
Yeah.
and Pakistan is here. So
Yeah.
so this is 2024, I suppose. It doesn't matter. But so I think that the crop residue burning in Pakistan side, of course, there is. I'm not saying that they're not existing, but there is. But I think that compared to what we have seen, what is see on satellites is remarkably high in Punjab. And as I also mentioned, like I think that this plot is that if we just simulate with all, yeah, but here we have the simulated using all the biomass burning, right? Like FIN as it is.
Yeah.
And we just run the model with just Punjab. That was the whole idea. Like, what is the contribution of Punjab in this case? So these two map, which shows very, very close in agreement, which means that, and we have seen like the Punjab and Haryana, for example, calculations, and the Haryana emissions are about 10 times smaller than Punjab.
I see.
Like this one. So here it's like a North Punjab, South Punjab, Haryana is here, and actually UP is coming up now in recent times, so slightly more. But I think that this like we have the scales are very low. I mean, you see the Haryana cannot be seen actually. So that the dominance of Punjab is seen in the what we have in the emission inventory currently.
I see. Thank you. Thank you.
Okay, and then there is a question in the chat where it's by V. Kumar. He is asking which instrument was used by JNU and CPCB. I believe the instrument used at all the three locations, including US Embassy, were VPAT and EBAN. This devices would be the because all the three locations is matching very well. Is it a comment or question? Okay. So, okay, before other people get hands, I have a question on this slide only, whatever you have opened right now.
Yeah.
So you were talking about this slide and you explained that why this CPCB data is low because of this water gun people were using for critical came down. But why you have a difference between EBAM and your sensor?
So
this is quite significant. Yeah.
Yeah.
Almost, yeah.
Yeah, so I think that then it also happens because these sites are not exactly same, right? So you know that how heterogeneous is the PM 2.5 concentrations because of the local emissions. We have also other sites I can within Delhi, they show very different concentration because they are in a different locality. And even like in Diwali times, you can see that the ITO is showing such a high value. But our observation site in JNU shows much smaller PM peak in the PM 2.5. So there is a difference between, and then the US Embassy is somewhere around cut here. There is a gap in the data of US Embassy. So we do not know whether it's a real gap or it's the instrument got saturated.
In a way, one can say that if the sources is very local, it's highly localized, then it is reflecting on that particular sensor. Otherwise, if it is more uniform for a given region, then you are getting similar concentration.
It depends, like what kind of climate situations we have in this case, and then what kind of the local controls, right? So sometimes we even like you also in Delhi, if you go there are some streets they spray water on the street. Like Ashoka Road, if you go in the night, you can see that they're spraying water on the street. But it will not happen in many other places. For example, if you go to Munirka, I mean, somewhere around there. So these local differences also very. This is what I'm trying to say here, that when you analyze this data, we have to be aware of so many things. I think I don't this case like it's not an instrumental problem. It is just the local differences, and something like that could happen. Like water gun could be like a next to the ITO in that time. I think this water gun also moves. So it depends on when they place and where they place. So we could see a difference in concentrations. So we have to be aware of many things when you do this analysis. And I am sure that we have so many sites and then CPCB and everybody's. I think that it can be there can be one study just focusing on this kind of case even, you know. So we have very less analysis done yet. And we are mostly looking at average picture of the region so far.
Now, next hand raised by Dr. Aditya Vaid from Hyderabad University. So, Aditya, please go ahead.
Hello, Professor Patra. First of all, thanks for this very elaborate and informative talk. And my question is more related to the sensors because we here at Ahmedabad University, we work on low-cost sensors. The concerns are based on our own experiences, these sensors differ within themselves. So we have deployed a network of roughly 20 sensors over Western India, Rajasthan and Gujarat. But when we are doing co-located measurements, it's like east, west, north, south, many of them giving spikes despite being located at the same place. So what's your experience, with these sensors and how reliable they are in long-term measurements?
Yeah, this is what we have. I'm showing. I mean, we have long-term measurements of several sites. So I think Matsumi Sensei is also in the audience today. He can speak. But this is what I'm trying to show you here. For example, look at we actually start these measurements from September. I'm just showing from October. So we have 30 instruments, right? So you can see that I am showing here almost like two instruments here, two instrument here, two instrument here, and one here. So 7 instrument results are here. So when you start the instrument like in October, you can see that all instruments starts in a similar level. But depends on the location. So the instrument picks up different signal later on because it's also linked to the crop residue burning.
Right. Well, I do agree on this. However, here the concentrations are like 150, 200 micrograms and so. But when we are talking about in the range like 50, 60, then sometimes we see like one is giving 20, other one is giving 50, some of the sensors 70 at the same location. Then it becomes difficult.
Yes, of course. So you to be very careful how you calibrate the sensor, and then you to be because these sensors are developed by Matsumi Sensei and then Panasonic Corporation.
And if you can give us some idea of once we calibrate for, let us say, is it good for like 6 months or 1 year something, or we need to calibrate more often?
I think that again, can Matsumi Sensei speak? If he's here, I mean, then it can be, you can hear from the horse's mouth.
Okay, fine.
Matsumi Sensei, can you speak about this question?
Hi,
Okay.
Matsumi speaking.
Yes.
Yeah.
Matsumi say.
0.5 sensors every year. So in summer, we calibrate the PM2.5 sensor in Japan. And every year we take back to Japan and then calibrate and then put back to India. So every year we calibrate the sensors.
Okay. And do you see significant differences when they arrive back at your facility?
Maybe longer discussion can be avoided.
Okay, sure. I will probably discuss over email. Thanks very much, Neeraj.
Yes,
Thanks very much, Prabir.
And we do that actually. When we bring back the instruments, we again check the linearity and then stability.
Sure. Thank you very much.
Yeah. And next question handled by Professor Imam Salim. Please, sir.
Nice to see you, Patra, online after a long time.
Thank you. Yes, it's been many years.
Yes. I was just wondering, what is in Delhi NCR region, what is the contribution to PM 2.5 from thermal power plants?
Oh, I think that should be quite big. And so I did not.
How does that comes into your conceptual as well as the modeling effort to really see the biomass burning pattern or the mix of biomass and thermal power plants and regular traffic?
This is a good question. So I think I just want to show you another different slide. And so we did I think we are very lucky to have the COVID. Sometimes we sometimes repented that we had COVID, that we could not go and do measurements. But so this is a kind of a figure you see. in this plot. And I think it should go to PowerPoint. Yeah. So these are, I think, very important point, because, and then we saw that this, that we can see the COVID happened, and the page 1, page 2, page 3, and this is, I think, most important figure in this case. So this is a NO2 from the satellites, and this is the normal conditions, business as usual from satellite. And you see that when the phase 1 of the COVID-19 was enacted, so you see that and these hotspots are actually thermal power plants, these hotspots. So then in the COVID time, the industry was stopped, and then even human activity also, like that vehicular things, everything went slowed down, only few were running, and very few power plants also was running in low power mode. So you can see some power plants was actually shut down. This one is shut down, this is shut down, but this one is, and this one is running because it's to supply the residential electricity. And this is the kind of, so then when in the COVID time, we had almost nothing, no difference between the urban and rural areas. The Delhi megacity is like the same as UP remote or Haryana west. I think this answers your question, because this happened in March, right? And then there is no crop residue bonding, everything is anthropogenic, just the human activity. So this has power plant, it has your vehicular, you have everything like all other the barbecues in the field or whatever it is.
Yeah, I think that's still a complex issue, even when you are going to come out of the COVID period and see the what is happening from the biomass burning emissions and what is the impact from thermal power plants. So that's, I think, is a key issue which all of us are trying to address, that the impact on the PM 2.5. The second, the second, I always advocate the philosophy of the PM 2.5 and health issue is mostly relates to the chemistry of the PM 2.5, the chemical composition. So I think that goes in the long way, that the one is of course, the PM 2.5 concentration, and another one is the chemical composition of the PM 2.5, especially in the Delhi NCR region, because of the thermal power plants.
Yes.
Because one of the major concern is what are the emissions which are coming from the SOx, NOx, all those things which are coming from the thermal power plants. So I think that's a very challenging issue in the on a local and regional scale for that.
Yes, I fully agree, and I think that Neeraj is the best person to even talk about that. I mean, they have been working on the oxidative potentials, and you have been part of the system also. I think those are the important questions we still have. I mean, how dangerous it is to breathe in the power plant, or the even crop residue burning should be quite high toxic, because it's a lot of black carbon in it.
Because both these polycyclic aromatic hydrocarbons coming from both power plants as well as from biomass burning.
Yes.
So I think that compounds the problem of that.
Yeah, I think that is, and I think that's what I mean. I went to Punjab, like I thought people will be okay because they are living there for this one. They actually tell the real story that they don't go out for 1 month in those months. I mean, even in teenager kids, they cannot go to the school, they say.
Yeah.
It was very stark and situation. And then I know colleagues in Delhi who take small kids, and they like a 10 years old or below. And it seems doctors suggest in Delhi that in the winter time, you please go out of Delhi if you want to be healthy. I mean, that's a reality, right?
Yeah.
But then situation has not improved over so many years, which is bit of pity to me. I mean, and we have, I think, enough knowledge in terms of scientifically, and then I think that also Neeraj have been part of the many papers which came out in Nature Communications and other places, is that they actually able to pinpoint the exact compounds. I mean, of course, maybe but in the just PM 2.5, I think it's quite dangerous for human health. If you just breathe every day, it's not so healthy. I mean, whatever composition it is. Well, of course, dust are different.
And then if you add further, it's a toxic component in that, then it becomes...
That's the whole issue there. Anyway, that's nice talking to you, Patra, and nice meeting you at least on the online, and
Yeah.
and hope to see you sometime in again this part of the world when you are visiting Amritsar and Golden Temple. So thank
Sure.
you,
Yes.
thank you.
Thank you. Thank you very much.
Next hand raised by Dr. Bhupen Kumar. Bhupen Kumar, would you like to directly ask?
Sir, good evening, sir.
Yeah, please continue.
Good evening, sir. I am a PhD scholar in Guru Gobind Singh University, working on the air pollution and dispersion modeling.
Yeah, continue.
Yeah, sir. Actually, currently we are monitoring for the black carbon in our university campus by accelerometer A33. It shows the uh, percentage in percentage of biomass burning through the accelerometer. It captures the data of the percentage, how much percentage it is contributing in the atmosphere due to biomass burning, and it shows the concentration of black carbon. I just want to know one thing, that how can we estimate the concentration of PM 2.5 through that black carbon concentration which we are obtaining in the by accelerometer, which will be very helpful for the human health risk assessment, because that black carbon is generating from the biomass burning. I hope my question is little bit clear.
Yeah, I think your question is, I understand your question, but I think you really have to talk to the people who work on who are expert in the aerosols. I am not an aerosol expert, I mostly work on the greenhouse gases, etc. And I mean, I know this kind of basic theory, but I think I will not be able to
Maybe I
reply.
can add a line here. So
Yes,
Bhupen,
go ahead,
is
please.
you cannot directly, you can make a relationship between PM 2.5 and black carbon, but that may not be uniform for all the sites. It will vary from place to place, and you
Yeah.
cannot have that much calibration. So that is not the best thing to think that from black carbon concentration you are calculating the mass concentration.
Okay, sir. Okay. Thank you, sir.
And there are some questions in chat box. If you allow me, I will read
Yeah,
them
yes,
out.
I have time as such, so yeah, no
Okay.
problem.
Then one is, I don't know the name because the name is admin. He's from Bangalore for the show. So he was asking, Mr. Sir, it was very informative talk. Is there any possibility to service Akash network in our place, Bangalore? People are, you are in demand from north to south.
I mean, yes, I mean, as I mentioned, like, I think that I mean, Indian government has to really plan this long-term monitoring system. I think one thing is that obviously that which is done by SOFR and those kind of sophisticated instrumentation, also like which is done by IIT Delhi and Kanpur, and Niraj, you do a lot in those kind of things. But I think simple PM 2.5 instruments should be able to be installed in many places with minimal effort. And I think that actually gives us some sort of idea about what is going on, and in terms of the particular air pollutions. Of course, there are, we know that dust events happens, those things happens, but I think those are kind of not dangerous for us. But the which is anthropogenically produced like by industrial activities, I think they are they remain stable, they remains I think quite harmful for our human health. And then as you mentioned that anything comes out of this burning industry like which is consuming fossil fuel, they are actually more dangerous than the mineral dust, for example. So we need to at least be able to monitor these things. And I think it's Bangalore, and actually if you go to Calcutta or if you go to other places, the things are becoming more serious. So any place, yeah, and then this mechanization, what I was discussing in this my talk, mechanization of the cultivation, farming is happening everywhere. Punjab was well ahead in this business, but now it is happening everywhere in the country, and it will happen more and more because we are doing crop intensification, and that residue is going to be more and more, because when you go for high yielding varieties, the plant has to be bigger and bigger to produce more and more. That's the basic theory. So if you don't have a strong plant, you don't produce don't produce high yield. So then, and this is intensification happening. The area of the crop is increasing because we are doing the, let's say, water harvesting, the water river linking. So the supply of water is getting more and more abundant in India, even in the semi-arid regions. So these things is going to be more and more, I think, and this transition has to be captured. To me, I mean, this transition has to be captured, and then how we do this and who take lead, and how the government help us on in this will be the things to see. And the idea of our project is to show one case that it is possible in a reasonable cost. That is the thing I would say.
Next question is by another student, John Vilya of IIT Pune. He's asking, is the WRF our model simulation control and capturing the fume coming from Pakistan during November 2024, along with transport from Pakistan, those seem more prominent for rising to 25.
Yeah, I mean, yeah, we do not really discuss the cross boundary air pollutions as such in this case. We are trying to think about the processes which affect the simulation in our case. We have not done any like a transboundary analysis in this case. So I will not be able to comment on which country is polluting which country. But I think that's a matter of also concern to some extent to me, because this will be more and more discussed in the international forums like IGAC and other places, because people are, and then there are discussion like in the Europe and US in the past, right, to tax the polluters. And it's the same concept also now going to the greenhouse gas emissions. So taxing the polluters, they pollute by greenhouse gas, they pollute by ozone precursors, or pollute by the PM 2.5 precursors. So those taxes are being discussed internationally, and then it has been there, not new anymore. But I think we did not do that kind of analysis in this case to talk about different country, different states. So that will be a new, I mean, you need to do slightly more analysis and research on that.
Next question by Chandrama, another student. Why particularly IGP is mostly affected by biomass burning? The burning takes place during October to November. At that time, wind direction changes north to east, but we see biomass concentration at that time. The concentration is completely.
No, so I mean, yes. So it is actually, as you mentioned, it's highly controlled by the meteorology, and then the topography up in that IGP. But I think it is northeast, but northeast wind at the surface, which is actually forced by the Himalayan that orography. And this crop residue burning and the crop cultivation in the Indo-Gangetic plain is rampant. I think the most intense, you would say, because of the supply of water and the land fertility. If you go to MP and most of the Chhattisgarh, they are not doing so much cropping in the past. So naturally, I think this part is the most polluted, and you can see them actually flowing in that direction by satellites as well. It's very clearly seen. And so the central part is not so active in terms of these practices, what we see. And the population density. Population density also is the highest in the IGPs. That means any activity you do is much more intensified by the demand and then consumption.
Number of people affected are also more.
Yeah.
Okay. And the last question is by Professor Shubha Vapa from IIT Kharagpur. And she's asking, how about measurements of OCBC besides PM 2.5? Because uncertainty in PM 2.5 is more difficult to understand. Further, underestimation may also be due to the desert dust, which is not captured properly in the most models.
Yeah, I think that desert dust is one thing, but I think in the season of like October, November, I don't believe the desert dust comes in this side. It comes slightly later when the ocean disturbances and other things sets up, where they can bring some desert dust in this area. Or also it happens in the monsoon, like a southwest monsoon, and before that time. So we see that a lot of dust also deposited in the Arabian Sea, and that is also linked to chlorophyll formations in the surface ocean. So those are already we see, but I think they don't come to the surface in this intensity in our area. Of course, when I was living in Delhi, we have seen that desert dust from the Thar has come to Delhi sometimes in the April in that time. So, but I have not seen the desert. I mean, this what we are talking here is about, let's say, very concentrated Punjab, in the Punjab, Haryana, and Delhi. And if you see our simulations, they are actually linked to the concentrations are linked to the emissions very much. They are not like a erratic in a sense. So we have basic understanding what is happening, but then the magnitude we don't get the right number very often. So there the lack of understanding is happening because of the what time we emit, what chemical composition we emit, what is the secondary productions happening. So those things obviously, as you mentioned, like OCBC things are important. And then I know that IIT Delhi now had Dilip and then his group, and they have a stations in Sonipat. And Lokesh is involved in that station also as well. They do like a how many 70, 80 VOCs measurements, and then they are doing also the black carbon and then other measurements. So they have a continuous site running year round or continuously since 2023 autumn.
Yes.
And in addition, since you are talking about PM 2.5, so dust should not be contributing too much to the final fraction.
Yeah.
So, yeah.
That's another thing. Yeah.
Okay. Another question is by now one more question came by Kamran Ansari. And he's asking, were cloud cover and peak burning times in 2024 similar to those in previous years? Because these factors can also contribute to the decrease in satellite technical platform.
Yeah, they vary, but I think as I was showing you in that, also I have another slide to show you. The cloud cover happens only in the October-November months, particularly when the most intense cloud residue burning happens, middle of October to middle of November. In that time, what we have seen, the cloud cover happens maybe in 2, 3, or 4 days. So that's all. I mean, so and when then also that associated also with the cloud cover, there is also rainfall. So which means that the people, nobody will go and burn things. So we do not. I mean, we have done the simulations actually in our case that if you can fill up those cloudy days by the emission maps, fictitious or the artificial emission map, the concentration does not change on when you talk about the 1 month average. They are only small fraction of the contributions. So we are able to capture most part of it. So I think that's not a big issue. That satellite that cloud cover will affect this kind of calculation. I think cloud covers are not so serious, significant factor in this case.
And then while you were answering one more question, where Dev Prashad, he is asking, do you have estimation of carbonaceous aerosol? CA means carbonaceous aerosol coming from this particular burning over Delhi. Any
it has to come, right? It has to come, and then that one like Dilip's and then Lokesh people have done analysis. It does show that there is carbonaceous aerosols in the PM 2.5. So of course it does, because then this aerosols lives for several days or maybe up to a week. So you can imagine how far they can travel. So I mean, we have seen the cases from Punjab to Delhi. It sometimes takes like just 12 hours to travel. And sometimes it can be even lesser hours. Sometimes it can be like maybe 1 day. But so 1 day is not enough to remove all the aerosols by gravitational settling. Unless a rainfall or something comes, it can of course wash out. But gravitational settling takes more than several days. So it will actually, it gets spread all over the place. It can go to Rajasthan, it can go to northern side, not so much, but Rajasthan is very frequently the emission plumes go to Rajasthan, Haryana, Delhi, and all the way to whole
I think
IGP.
he was probably trying to understand the quantification, whether means if you have public aerosol or conventional aerosol, so how much is from PRB and how much is from other sources? Probably that everybody was trying to understand.
Yeah.
But yeah, it is difficult from the things that are.
These are research questions, yes, obviously are there. I mean, but the issue also is that how many instruments can you deploy of those kinds, but eventually we want to understand those things. You're right. Yeah.
So there are no more questions. So now we are coming to the last part of the talk, which is vote of thanks. So for that, first of all, I wish to thank Professor Patra for accepting our invitation. Promptly accepting means I wrote and he said yes, why not? When you want. And I said on 27 he said yes, please go ahead. So thank you very much for accepting our invitation to be the talk. And then I would also like to thank the BARC team who is doing actually all the work. They are making flyer to arranging the lecture and they are doing. So thank you very much. And most importantly, I wish to thank all the audience. It is you because of which we are taking trying to hold the lecture. Speakers are giving the lecture. It is all for you. So please keep coming and try to get knowledge from different lectures. And one more thing I would like to say to all that this year IASTA is going to host Asian Aerosol Conference in Bombay during December 1st to 4th. So please plan and come, and not only with the national researcher, but try to share your research with national researchers as well. So we invite you all to contribute to ASC 2025. And with this, thank you very much.